Hey, welcome back to my channel. Today the journey continues with an interesting topic. I'll present the bisection method and show how it can be applied in video games, especially problems like collision detection. Numerical methods are essential tools in computation. They help us approximate solutions to equations where no closed-form solution is practical. Root-finding methods like the bisection method are particularly useful. In video games, equations appear often in physics, AI, and graphics. What is the bisection method? The bisection method is a simple algorithm for finding roots of continuous functions. If a function changes sign between 2 points, then we know a root must lie between them. By repeatedly cutting the interval in half, we can narrow down where the root is. Steps of the bisection method. Pick an interval from a to b and then we plug in function a and b values. They must have opposite signs. Also compute the midpoint. In addition, we evaluate the function at the midpoint. Furthermore, we replace either a or b with the midpoint depending on the sign. And in the end, we continue until the interval is very small. It's guaranteed to converge, although not very fast. As an example, we have a function x to the power of 3 minus x minus 2 in the interval 1 to 2. If we plug to the function the values of 1 and 2, we respectively have function values minus 2 and 4. Since the signs are different, a root lies between them. Repeating the section steps give us the root near x equals 1.521. And now application in video games. In video games, you often need to solve equations like this. Examples include collision detection, physics simulations, projectile trajectories, AI decisions, and even rendering optimizations. The bisection method is valuable because it's reliable and easy to implement. Imagine a scenario. A grenade is thrown upward from height 1.5 meters with an initial vertical speed of 10 meters per second. At the same time, an enemy is moving upward on an elevator and speed of 2 meters per second. We want to know if and when the grenade and the enemy meet. Not to forget, the gravity force equals to 10 meters per second squared. Obviously, the answer is given by physics classical equations. We have the equation of projectile, we have the equation of the target. The equation of the projectile is a free fall upwards, that's why the negative sign appears in front of the square. And for the target, we have the equation of constant speed. The collision happens when the two equations are equal to each other. Subtracting and equating to 0, we get the root function, which is 1.5 plus 8 multiplied by t minus 5 multiplied by t squared. We select a root between 0 and 3 seconds. The interval is determined if we want a collision fast or slow. Suppose our video game is a game with superb action, we want the collision to happen within seconds. Applying the bisection method step by step narrows the interval. We plug the values of 0 and 3 to our function. Respectively, the values functions are 1.5 and minus 18.6. After 12 iterations, we find the time approximately to 1.801 seconds. At that time, both the grenade and the target are about 3.6 meters high, so a collision occurs. Advantages and limitations. The advantage is reliability. If there is a root, bisection will find it. The limitation is speed. It converges slowly compared to Newton's method, another root finding method. Also, we need a sign change interval to begin with. To conclude, the bisection method is a fundamental numerical tool. It's not only a nice mathematical exercise, but also directly relevant to problems with video games, like collision detection. Understanding it helps us appreciate how much powers realistic gameplay. And pay attention. This work is even more complicated with a lot of parameters. It depends on the size of the game either way. Thanks for watching. If you like this video, hit like and subscribe. Got a topic in mind? Comment below. See you next time.